All right. Welcome back. We're going to take a look at sketching a graph of a known parent function that has been transformed. We've been furnished here with some transformations, and we're going to show how to use the arrow diagrams to come up with what this graph should look like. So, to begin with, we are transforming the absolute value function, so I'm going to start with an arrow for absolute value. Okay. So there's our absolute value parent function. Looks a little sad. The first thing it says is do a reflection over the x-axis. X-axis is horizontal, so reflections over that are vertical reflections. So since it's a vertical transformation, we want to go, that's an adjustment to the output. And we're going to make an arrow on the output side and say do a sign change there because that's what reflections are. Okay. Second one here says shift to the left 2. That's a horizontal thing, so that's making a change to the input of the parent function. So I'm going to put that over here, and there is my left 2. It's a shift, so it's adding or subtracting, and the negatives are on the left, so it's a subtract there. And then we're going to vertically stretch by 5. It tells us vertically. The next place I have available to put an arrow is over here, so I will multiply that by 5 right there. Okay, and so the question is, how does this help me graph? Well, it does if I know some things about my parent function. And for this parent function, I know that important values here happen at -1, 0, and 1. Okay. So when I use those as inputs to my parent function, I get outputs of 1, 0, and 1. So I'm going to plot my parent function over here. I've got a point at -1, 1, at 0, 0, and at 1, 1. And that's really all I need to know where this goes, in addition to the fact that it's an absolute value, so I know it should be shaped like a V. So here's the vertex of that V. My alignment of my screen is off here just a little bit, so it's not quite falling in the right spot. But that's basically what it looks like here. I'm going to pause this and align my screen and try to fix that. Okay, so right where I put it. Now all we're going to do is do what the arrows tell us to do. Okay, so this arrow says change the sign on whatever the input was. Well, my inputs are in a list right here at the beginning of that arrow. So the 1, change the sign on that, becomes a -1. 0 is still 0. This becomes a -1. And now I have some inputs for this multiplied by 5, and it says multiply all of those numbers by 5. Okay. Over on this side, my inputs to the blue arrow are the inputs to the parent function, because I'm moving away from it here, and it says subtract 2 from those. So -1 minus 2 is -3. 0 minus 2 is -2, and -1 minus 2 is -3 again. And so I get points to plot here. My points are -3, -5. That's the input from the far left connected to the output on the far right. My vertex, because this is where the vertex was to begin with, is now at -2, 0. And I have another point on there at -3, -5. So I'm going to plot those points and see where they are now in my transformed function. So -3, -5 is right here. And -2, 0, that should be where my vertex is now. And let's see, what did I do? Oh, this should have been my input on this end, should have been a +1, not a -1. Doesn't do me any good to map the same input to different places. So that still comes out as a 1, but 1 minus 2 is now a -1. And so this point should be at -1, -5. -1, -5 is there, and I can see that I've started my vertex. and I go through the point and vertex through the point, and that is the graph of my transformed function. Doesn't actually stick above the x-axis there at all. But that's how I can use an arrow diagram to graph a function. Extra information that I could get from this that may or may not be helpful. I know that I can put the domain of this, the domain of the absolute value function is all real numbers, but the range is y greater than or equal to 0. When I subtract 2 from all real numbers, that doesn't really change anything. I can't modify all real numbers that way. Over here, this says I change the sign here. When I change the sign on the inequality, I have to change the direction of the inequality. The 0 still is 0. But then if I multiply that by 5, it's still 0. And it tells me the domain of my new function, my transformed function, is all real numbers, but the range is all values of y less than or equal to 0. And I can definitely see that in my picture. Okay, this does not matter what the parent function is to begin with, as long as you know where the points are that you're putting in there, and then you can transform those points, plot them, and make the curve that you know is supposed to be there through those points.